Assalamualaikum. My name is Arija Noor and I will be presenting in front of you today complete analysis of the COVID-19 dataset. Next slide. I've imported this dataset from Kaggle using Pandas library. Next slide. Here we are going to look into the measures of central tendency for the column of confirmed cases. As we know, we have three main aspects or measures of central tendency: mean, median, and mode. Here, looking into mean, we have three different types of mean: arithmetic mean, geometric mean, and harmonic mean, each having their own significance and importance. Next slide. Arithmetic mean provides an average number of confirmed COVID-19 cases across the dataset. It can help us to understand the overall level of confirmed cases, which can indicate the severity of the pandemic. Whereas, on the other hand, geometric mean is more appropriate for multiplicative data and can provide a better central tendency when dealing with skewed distributions. The harmonic mean is very good while we're dealing with large outliers, and it's very helpful and useful to make an understanding of average rate of cases. Next slide. Here you can see the Python implementation of grouped data as well as ungrouped data of all three means. Next slide. Moving on to median and mode. Median gives the middlemost value of confirmed cases when they're sorted. This makes median the robust measure of central tendency that is not affected by outliers, providing a better sense of the typical case count. Where, on the other hand, mode identifies the most frequently occurring number of confirmed cases. Understanding the mode can highlight the common case count, which can indicate typical outbreak sizes. Moving on to the next slide. Measures of dispersion. We have four main measures of dispersion: range, mean deviation, quartile deviation, and variance with standard deviation. All of these indicate the spread of data. In the next slides, we have Python code implementation of grouped and ungrouped data of all of these four measures of dispersion. In order to conclude the significance of these measures, I would say the range, variance, and standard deviation calculations indicate a wide spread of number of confirmed cases across different regions, indicating that some areas have a very high count while some areas have a significantly lower count. This further emphasizes the relative variability in case counts and allows easy comparison. Next slide. Measures of skewness. We have two main methods to determine the measure of skewness: Carl-Pearson and Bowley's method. Next slide. Measures of skewness. We can find measure of skewness by two main methods: Carl-Pearson and Bowley's coefficient. Looking into the significance of measuring skewness, we can see that it helps in analyzing resource allocation. मतलब ये है कि इनमें से जो भी एरियाज हैं जिनके अंदर ज्यादा केसेस फाइंड आउट हो रहे हैं उनको हम उसी हिसाब से ज्यादा रिसोर्सेज प्रोवाइड कर सकते हैं. Moving on to forecasting and planning. Determining skewness can also help in forecasting. इसका मतलब ये है कि हम हमारे पास जो ऑलरेडी गिवन इंफॉर्मेशन है उसको देखते हुए हम ये प्रिडिक्ट कर सकते हैं कि फर्दर आउटब्रेक्स किन रीजन्स में होंगे, और आउटब्रेक होने से पहले ही वी कैन फोर्स लॉकडाउन इन दीज रीजन्स ताकि हम वो आउटब्रेक प्रिवेंट कर सकें या फिर उसको उतनी सिवेरिटी से होने से रोक सकें। मतलब कहने का ये है कि स्क्यूनेस हमारी हेल्प करती है ये चीज़ फाइंड आउट करने में कि किस रीजन को ज़्यादा रिसोर्सेज चाहिए और किस रीजन को कम रिसोर्सेज चाहिए। सो ये करने से हम इनइक्वालिटी रिड्यूस करते हैं और इंक्लूसिवनेस मेंटेन रखते हैं। हमें क्रॉस वैलिडेशन होती है, हम जनरल ट्रेंड्स का पता रख सकते हैं कि कहाँ केसेस बढ़ रहे हैं, कहाँ केसेस कम हो रहे हैं और क्या रीजंस हैं इन केसेस के बढ़ने के और केसेस के कम होने के। फर्दर मोर, अगर किसी भी रीजन में आपने कोई भी आउटब्रेक कंट्रोल करने का मेथड यूज किया है तो आप उसकी इफेक्टिवनेस मॉनिटर कर सकते हैं कि किधर केसेस कम हो रहे हैं, किधर ज़्यादा हो रहे हैं और आपके मेथड्स काम कर रहे हैं या नहीं कर रहे और कौन से मेथड्स ज़्यादा काम कर रहे हैं और कौन से मेथड्स कम काम कर रहे हैं। Moving on to moments, we have three types of moments: moments about mean, moments about origin, and moments about the arbitrary origin. Moments about the mean हमें बताते हैं shape और spread of the distribution around the mean. अब हमने पीछे मीन निकाला था ना, उसके अराउंड जो हमारे पास स्प्रेड होगी इंफॉर्मेशन की वो हमें मोमेंट्स अबाउट द मीन एक्सप्लेन करते हैं। The second moment indicates spread, while higher moments can indicate the presence of outliers in the overall shape of the distribution. Similarly, moments about origin provide information about the shape and spread around the distribution around zero. And around the arbitrary origin, these provide information about the shape and spread around of the distribution around a specific chosen point. Now we are going to look into how we can visualize the data with grouped and ungrouped formats. I have represented my ungrouped data in two forms: bar chart and pie chart. The bar chart is used to compare categorical data while the pie chart is used to show proportions as a whole. विजुअलाइजेशन हमारी काफ़ी चीज़ों में हेल्प कर सकती है, जैसे कि इम्पैक्ट असेसमेंट, कि आप इम्पैक्ट अपना स्टडी कर सकते हो कि आपके हेल्थ केयर सिस्टम्स का क्या इम्पैक्ट हो रहा है आपके आउटब्रेक के ऊपर। आप रिसोर्सेज प्लान कर सकते हो कि किस जगह पे आपको ज़्यादा रिसोर्सेज चाहिए, आईसीयू बेड्स चाहिए, वैक्सीनेशन चाहिए, ट्रीटमेंट फैसिलिटीज़ चाहिए। आप अपनी हेल्थ केयर की एफिशिएंसी मॉनिटर कर सकते हो। और स्पेसिफिकली जो सबसे ज़्यादा यूजफुल जो विजुअलाइजेशन होती है वो आपके लिए पब्लिक कम्युनिकेशन में होती है, बिकॉज इट्स सो ईजी टू अंडरस्टैंड, इवन अ ले मैन और लाइक अ स्टेक होल्डर कैन लुक एट इट एंड अंडरस्टैंड, and they don't need to go into the more complex formulations behind these results. In grouped data analysis, I've used a histogram and a frequency polygon in order to visualize and to show you the trends all over the data. I've made these to focus on patterns. These help uncover the hidden clusters or trends that are not visible in raw data. इनको देख के हम आसानी से बता सकते हैं कि कहाँ अनएक्सपेक्टेडली हाइज और लोज आए थे केसेस के अंदर। This makes comparing really easy. You can have like a side to side comparison without distortion. Furthermore, we have an OGIF. Now, this is an OGIF. It is a cumulative frequency graph that shows the distribution of data. Helping us visualize the cumulative frequency of each class. In order to conclude, this Now, this is an OGIF. It is a cumulative frequency graph that shows the distribution of data. Helping us visualize the cumulative frequency of each class. In order to conclude the significance of our visualization, I would say the insights gained from this analysis can guide health officials in making decisions and in intervention strategies. For example, understanding which regions have a high case count can help prioritize vaccines and healthcare resources to those specific areas. These statistical measures can also be used to communicate with the public to raise awareness and encourage compliance with the health guidelines. Now we're going to look at the Python implementation. Firstly, importing data and printing it out. Secondly, we're going to look at all implementations using ungrouped data and then grouped data. Starting with ungrouped data, we have all three means. As you can see, I've added a small number in the geometric and harmonic mean to prevent zero digits or zero values. Furthermore, calculating median and mode by the same libraries of Skippy stats. Furthermore, finding quartiles which help in analyzing spread and determining outliers. Then finding deciles, then finding percentiles in the very same way that we found it quartiles. Now we're finding the measures of dispersion as talked about in the presentation as well. These are the measures of dispersion for ungrouped data. Finding the coefficient of all of these can also determine the spread and can help us analyze the spread. Here we are finding skewness by Carls Pearson and Bowley's coefficient. Calculating moments about mean, moments about origin, and moments about arbitrary origin. Here we are assuming an arbitrary origin because when we want to find out the moment about an arbitrary origin, we are trying to find out the moment around a specific point. And here we've assumed the specific point to be 100. Now we are going to plot confirmed deaths and confirmed deaths and recovered cases for bar chart so we can visualize and so it would be easier to understand. Similarly, plotting pie graph. Now repeating all of these steps for grouped data, but first we will convert the ungrouped data into grouped data by creating an algorithm which determines bins and bin width. Bin width is basically size of our classes. And by bin, after determining our bin width, we actually determine how big each class is going to be, and we're going to convert bins into classes after determining the frequency of each bin. Now we're going to calculate arithmetic, geometric, and harmonic mean by grouped data, median, mode by grouped data, all three quartiles, all 10 percentiles, deciles, moments of dispersion, coefficients of moments of dispersion, Carl's Pearson's method and Bowley's method for skewness, moments about mean origin and arbitrary origin. In this similar way as we did for ungrouped data, we are going to plot an histogram for visualization. In this, we can't get a correct histogram because of the large number of outliers and zero values in our data. So we need to convert and clean our data by applying log. We can plot our log transformed distribution into an histogram for confirmed, death, and recovered. We are going to do the same thing with frequency polygon. We have three frequency polygons: recovered, deaths, and confirmed. Now we're going to use the cumulative frequency in order to find ogive. Calculating